Have you ever wondered what causes earthquakes and volcanoes? These natural phenomena have been a source of intrigue, fascination, and fear throughout human history. They've inspired tales of wrathful gods and apocalyptic visions, but the true explanation is not mystical, it's geological. In fact, the key to deciphering the mystery of earthquakes and volcanoes is right beneath our feet. Our planet is not a solid, unchanging sphere, but rather a dynamic, constantly shifting entity. It's like a gigantic jigsaw puzzle, comprised of enormous pieces that we call tectonic plates. These plates, which make up the Earth's crust, are in constant movement. They slide, bump, and grind against each other on a layer of the Earth known as the lithosphere. Sometimes they move apart, creating a gap where molten rock from the Earth's mantle can seep up and form new crust. This is how our oceans were formed. At other times, these plates collide in a slow-motion battle of titanic forces. It's here, at these collision points, where we find the majority of the Earth's volcanoes and earthquake zones. When one plate is forced beneath another in a process called subduction, the intense heat and pressure can trigger earthquakes and volcanic eruptions. Imagine two massive, rocky slabs, each many miles thick, grinding against each other with the weight of continents behind them. The friction is immense, and when the strain becomes too much to bear, energy is released in the form of seismic waves. These are the earthquakes that we feel. Similarly, when a plate is forced down into the mantle, the rock melts and forms magma. This magma rises through cracks in the Earth's crust, and if it reaches the surface, we see a volcanic eruption. So, the next time you hear about an earthquake or see footage of a volcanic eruption, remember that these are not random events. They are the result of the immense geological forces at work beneath our feet. So, if you've ever wondered why the Earth shakes or volcanoes erupt, the answer is tectonic plates. But what are these tectonic plates, you might ask? Well, let's delve into the world beneath our feet, where the Earth's crust and uppermost mantle combine to form the lithosphere. Within this lithosphere, we find the tectonic plates, colossal fragments that float on a semi-fluid layer of the mantle beneath them. Imagine a boiling pot of soup, with a thin film of oil floating on top. The soup here represents the semi-fluid mantle, while the oil mimics the lithosphere. The oil film, just like the lithosphere, isn't one unified layer, but is divided into multiple sections that move independently. These sections are what we call tectonic plates. Now, these plates are not static, they're constantly on the move, albeit at a pace slower than a snail's crawl. We're talking about a few centimeters a year, so don't expect to see any dramatic shifts in your lifetime. Much like pieces of a jigsaw puzzle drifting on a watery surface, these plates slide past, collide with, or move away from each other. And here's where things get interesting. The boundaries where these plates interact are hotspots for geological activity. When plates scrape past each other, the tension can lead to earthquakes. Where one plate is forced under another, a process called subduction, we see the formation of volcanic arcs and oceanic trenches. And where plates pull apart, new crust is created in the form of mid-ocean ridges. So these tectonic plates, these vast pieces of the Earth's lithosphere, are the hidden architects of our planet's surface. They shape the continents, carve out the ocean basins, and are responsible for the dramatic landscapes we see around us, from the highest mountain peaks to the deepest ocean trenches. So in essence, tectonic plates are giant puzzle pieces that make up the Earth's surface. Their movement and interaction give rise to the dynamic world we live in, a world that is constantly changing, evolving, and reshaping itself. Now, you may be asking, when did we discover these tectonic plates? Well, the story takes us back to the early 20th century, to the work of a German meteorologist named Alfred Wegener. Wegener was a curious mind, just like ours. He observed that the coastlines of Africa and South America seemed to fit together like puzzle pieces, almost as if they had once been joined. From this simple observation, he proposed an audacious theory in 1912, the theory of continental drift. He suggested that the continents were not fixed and static, but rather they were slowly drifting around the Earth. However, Wegener's theory was met with skepticism. His contemporaries found it hard to believe that continents could move. The missing piece of the puzzle was how these massive landmasses could drift across the globe. And so, Wegener's theory, though revolutionary, was largely dismissed. Fast forward to the mid-20th century. With the advent of new technologies, scientists began to explore the ocean floor, and what they found was astounding. They discovered a system of mid-ocean ridges, mountain ranges beneath the sea, where new seafloor was being created. This process, termed seafloor spreading, suggested that the continents were not so much drifting, as they were being pushed and pulled by the creation and destruction of the ocean floor. Adding to this, scientists also found patterns of magnetic striping on the seafloor, aligning with the Earth's magnetic field reversals. This provided further evidence of seafloor spreading, and consequently, the movement of continents. These discoveries, combined with Wegener's earlier work, led to the birth of a new scientific theory, plate tectonics. This theory proposed that the Earth's crust, or lithosphere, is broken into large pieces called plates, which move around due to the convection currents in the Earth's mantle. So it was only in the mid-20th century that we began to truly understand the existence and importance of tectonic plates. The discovery of these massive, shifting plates gave us a new perspective on our dynamic and ever-changing Earth. So, just how many of these tectonic plates are there? You might be wondering. Well, our planet is like a giant jigsaw puzzle, made up of large pieces known as tectonic plates. There are 7 major tectonic plates that cover the Earth's surface, each named after the geographic region they cover. These are the African, Antarctic, Eurasian, Indo-Australian, North American, Pacific and South American plates. But the Earth's crust isn't just made up of these 7 giants. There are also many minor plates. Some are even as small as a few hundred kilometers across, dotting the planet's surface like puzzle pieces waiting to be fitted into place. But these plates aren't static. They're constantly moving, albeit at a pace slower than your fingernails grow. This movement is what causes the interactions at their boundaries. Imagine 2 of these massive slabs of Earth's crust grinding against each other. When they collide, slide past one another, or move apart, it can lead to significant geological activity. Take the Pacific Plate, for example. It's the largest of the lot, covering more than 1/5 of the Earth's surface. It's also one of the most geologically active, with its boundaries marked by a series of volcanoes known as the Ring of Fire. Now, isn't that a dramatic name? On the other hand, the African Plate, another one of the major plates, is slowly splitting apart along the East African Rift. This process is creating a new oceanic plate, which, millions of years from now, will become a new ocean. Talk about slow and steady winning the race. So as you can see, the Earth's crust is a complex world in and of itself. It's not just a solid, immobile shell, but a dynamic and ever-changing landscape. It's this constant, albeit slow, movement that shapes our world, leading to the creation of mountains, valleys, and ocean trenches. So the Earth's crust is made up of a complex network of major and minor tectonic plates. Each one, with its own story to tell, shapes the world as we know it. But why should we care about these tectonic plates, you might ask? Well, the truth is, these seemingly unassuming layers beneath our feet play a vital role in shaping our world and, consequently, our daily lives. The movement of tectonic plates can trigger natural disasters such as earthquakes and volcanic eruptions. Imagine living near the edge of a tectonic plate, where the ground beneath you is constantly shifting. This movement, while often imperceptible, accumulates over time. Suddenly, the tension releases, causing the ground to shake in an earthquake. You can think of it like a snapped rubber band after being stretched too far. Volcanoes, on the other hand, are a fiery testament to the power of tectonic plates. When one plate slides under another in a process known as subduction, it melts into magma due to the intense heat and pressure. This magma can rise to the surface, resulting in a volcanic eruption. It's as dramatic as it sounds, with the potential to alter landscapes and impact climates. But it's not all doom and gloom. Understanding the mechanics of tectonic plates allows us to predict and prepare for these disasters. Scientists can monitor the movement of these plates, studying patterns and anomalies. This knowledge can, in turn, inform early warning systems, helping to save lives during earthquakes and volcanic eruptions. Moreover, the movement of tectonic plates has created some of the most breathtaking natural wonders on Earth. The Himalayas, for instance, owe their soaring heights to the collision of the Indian and Eurasian plates. Similarly, the Great Rift Valley in Africa is a result of two plates moving apart. So, while tectonic plates may be out of sight, they should never be out of mind. Their constant movement shapes our world, from the ground we walk on, to the mountains we admire, and even the natural disasters we fear. Understanding these plates and their impacts helps us appreciate the dynamic planet we call home. Thank you for tuning into this video. If you made it this far in the video, a huge thanks is in order. Like this video if you learned something, and subscribe for more content.